Hello everyone, Galen here again. And today's presentation was put together by Sharad, so if you happen to see him, tell him thank you. This next week's lab is going to be acceleration in one dimension. All right, so here we are continuing from last week. Last week we looked at both the position and the velocity graphs. The position being the displacement from the origin, and the velocity being the time rate change of the displacement. Now, if you'll remember, the slope of the position versus time graph was your velocity. Now this week, we're going to look at the slope of the velocity versus time graph, which is your acceleration. Now acceleration is defined as the time rate change in the velocity. So what is a position versus time graph? What is a velocity versus time graph? What is an acceleration versus time graph? And how do these features translate into the features of one another? Now last week we did deal with the first two, and now we're just going to add the third, and you're going to see how they interact with each other. Okay, for the position versus time graph, imagine rolling a ball along a table illuminated by a strobe light every second. This is a similar concept to what we talked about at the end of the last lab. So here we have a ruler with the ball rolling along, taking a picture each second at each centimeter. Now here is your position versus time graph. You can plot the ball's position as a function of time. You see how it's nice and evenly straight, and that the slope is going to give you the velocity. Notice that the graph is a straight line and is angled upward with a positive slope. This tells you that it's moving at constant speed with zero acceleration. Each type of motion has a characteristic shape on a position versus time graph. You have constant speed, zero speed, or you're sitting at rest, if you're accelerating or decelerating. Okay, now I need you to think back to your time in algebra and think about what is the definition of slope. Slope is just the rise over the run, and it's quite simple to calculate, as you can see here. Here are the three graphs of an object at rest. So the position is sitting at some place away from the center of origin, say at 1 meter. Now if it's not moving, of course there's zero velocity, so there is zero on the velocity versus time graph. And if there's zero velocity and it's not changing, then you also have zero acceleration. Okay, and here we have the three graphs of an object moving with constant velocity. In the position versus time graph, you can see that it is moving away from the origin at constant velocity, so the slope is just a straight line. Now, for the velocity versus time graph, you notice that the slope equals zero because there is no acceleration. So whatever the slope of the position versus time graph will be the number that the velocity is on the velocity versus time graph. And because the velocity versus time graph has a slope of zero, your acceleration is also zero. Here we have an object that is speeding up. Notice how it starts off, the slope is fairly shallow, and then as time goes on, the slope gets steeper and steeper. Here you have a constant slope, which is a nice straight line angled upward, which tells you that you are accelerating. And then whenever you see the acceleration versus time graph, the slope equals zero, but the number will be the slope of the previous graph. Okay, so here are your accelerating or speeding up and your slowing down graphs, both of them in the positive direction. So the first graph, the one on the left, shows you that you're starting off slow and you're getting faster and faster and faster. Now the other one is more like you're starting off fast, but you're getting slower and slower as you move away from the origin. If the line on the velocity versus time graph has a positive slope, the object is undergoing acceleration in the positive direction. Also, if the v is positive, then the object is speeding up. If the velocity is negative, then the object is slowing down. What you can do is use one finger to point in the direction of motion, and then use your other finger to point in the direction of acceleration. If they point in the same direction, you're going to speed up. If they point in the opposite direction, you're going to slow down. Here's an example of that. You have positive velocity and positive acceleration, so the velocity is getting faster. Here you have negative velocity but positive acceleration, so it slows down. Notice how the line goes towards zero as time goes on. Much like last week, we're going to be using the motion detector, but this time we're going to be adding a cart and track. So the rules for using the position sensor are going to be the same. If you hear it clicking, you know it's working. And you're going to observe what you see on the screen and correlate it to what's going on the track. Here is a picture of our next piece of new equipment. This is the fan cart. It's going to go up and down on the track. The track should be level. If your fan cart is moving without the fan on, then we may need to re-level the track a little bit. There, over by the door, you should see either yellow or red colored level that you can use to level the track. Now, this cart should be plugged in when you first get into the lab. It runs on a rechargeable battery, so you want to unplug it before you use it, but plug it back in before you leave for the day. Now the fan will swivel 180 degrees so it can push from either direction. And don't be afraid to play around with the settings. You can set it so that it has a time with which the fan will pulse, so it'll stay on for 1 second or 2 seconds or 3 seconds. You can also adjust how fast the fan, or how hard the fan blows, so you can get to more or less acceleration. Okay, so here are some things to think about. What if you have positive velocity and negative acceleration? What if you have negative velocity and negative acceleration? What if you have negative velocity and positive acceleration and positive velocity with zero acceleration? Think about these things. They may show up on the rat at the beginning of your next lab. Okay, here's a couple of things to remember. As you did last week, you're going to be setting up part of your lab today, so not everything is going to be ready to go. Please make sure that all the equipment is returned to its original place to give the next lab that comes in after you the pleasure of setting up their area also. Table 7 will be set up as a reference for you, so if you want to see how something should be set up, you will have an example to look at, so you're not left completely hanging. All right, guys, well, enjoy this next week's lab and have fun. Talk to you later. Bye-bye.